One of the things we often do in the lab when we measure the volume of a gas is we will collect it over water. And what you need to know is that when you're collecting something over water is that you have not just the gas you're collecting, like the gas that you're generating by the chemical reaction, you also have water vapor. And that water vapor you have a higher amount of it if you have higher temperatures, right? Because the water, more molecules having enough energy to escape the liquid. So what you need to always do is adjust for how much of the pressure comes from the water vapor. And in order to do that, you use a table that I think there is one in our index in our book. And you adjust for, you subtract off the pressure due to the water vapor. Okay, so to find the pressure of the desired gas, one must subtract the vapor pressure of the water from the total pressure. Alright, and we'll see how we do that. Okay, a sample of potassium chloride is partially decomposed, producing oxygen gas that is collected over water. We're given the balanced equation. The volume of the gas collected is 0.25 liters at 26 degrees C in 765 torr. So how many moles of oxygen are collected and how many grams of KClO3 were composed? This is a nice problem. So I'm collecting this gas over water and I know the total pressure is 765. So what I need to do is adjust this pressure. I need to subtract the pressure due to the water vapor. So I go to the appendix in the book that has vapor pressure of water at different temperatures, and what I will discover when I do that is this is 25 torr, specific to temperature. Alright, so I'm going to subtract those 25 torr, which comes from the water vapor, and what that leaves me is 740 torr associated with the gas. Okay, so we first want to know how many moles of oxygen are collected. So PV equals nRT. Moles is going to be PV over RT. My pressure is 740 torr. I'm going to divide that by 760 torr to get my ATM, and when I do that I get 740 divided by 760, and that gives me 0.97368 atmospheres. I'm going to leave a bunch of sig figs, right, because we don't round until the end. That's ATM. My volume is, let me see, 0.250 liters over R, which is 0.08206 liters atmospheres over moles K, times my T, and T is 26 degrees C, so that's going to be 299 K. And if I punch that, I got 0.97368 times 0.25 equals divide by, in parentheses, 0.08206 times 299, close my parentheses, I get 0.099, looks like I can have three sig figs, 0.0992 moles of oxygen. And then the question is, how many grams of KClO3 were decomposed? So here I just use some simple stoich, right? I know how much oxygen I have, and I'm trying to figure out how much of this needed to decompose to give me that. So I'm going to start with my moles of oxygen, which is 0.0992 moles of oxygen. And what I know from the stoich, from the coefficients, is 3 moles of oxygen come from 2 moles of KClO3, and I know that 1 mole of KClO3 is molar mass of that comes out to be 122.1 or 122.6 grams, and that will give me, if I plug and I chug, I get 0.811 grams of KClO3. Okay.